secure the main line to the A-frame.
Check the tension on line 3. Make sure the bridle is clear before the next swell.
The laser array provides a high-resolution point cloud, essential for assessing the fuselage's structural integrity.
Ease the tension on line 4. Make sure those shackles are secure before the next lift. We got it! Incredible, look at that. We actually did it. The structural integrity is compromised right here. We'll have to reinforce this section before the transport.
Hangar control coming in slow.
Copy that. Easy on the starboard side. Watch the tail clearance.
Pay close attention to these rivets. The structural integrity is compromised. We'll start with a localized repair plan. The aged paper clearly shows the hydraulic lines running through this bulkhead. We must ensure the rendering matches exactly. You can see projected here, the fatigue on the forward bulkhead is critical. We need a detailed plan for extraction before moving to the fuselage. Resource allocation for the hydraulic system is finalized. We move forward on Monday, ensuring we meet the Q3 targets.
Hoist. Keep it steady on the hoist. Now slow traverse to the left.
Keep the pressure steady on the hydraulics. We're clear on the port side.
Copy that, lead. Pressure holding steady.
We need to bypass the primary retraction valve.
Okay, I'm tracing the wiring now. It's really corroded here. Verify this connection point before I log the image.
Reading confirmed on the schematic. Proceed.
All right, team, easy now. Watch the port side. We have residual contamination readings here.
Copy that, moving slowly.
The diagnostic tablet is showing an open circuit here.
That explains the cold solder joint on the capacitor bank.
Desolder the IC carefully. We can't risk lifting that pad.
Understood. Proceeding slowly.
Make sure the CAN bus alignment is precise before you lock it down. We only get one shot at this integration.
Flow rate holding steady at 450 pph.
Confirmed. The atomization pattern is perfect.
That's 50 foot-pounds on blade 12. Roger that. Structural integrity is nominal.
Final calibration check complete. The efficiency gains look promising.
The integration is seamless. We're ready for testing.
Run the diagnostics on Bank 2 again. We need absolute certainty on the pressure sensors.
Already on it, verifying now.
RPMs holding steady at target. Temperature curves look good across all 3 sensors. Thrust output is normalized.
The resin cure temperature is critical here. Keep the lamp steady and monitor the surface for any voids.
Cross-reference the P501 bundle with the main schematic.
Confirmed. Routing it through the starboard conduit now.
Calibration sequence initiated.
Reading stable at 98%.
Acknowledged. Surface response is nominal.
Ensure the pressure line is secure before engaging the control unit.
I'm checking the torque now.
Alignment looks good on this ducting.
Easy now, watch the alignment on that cushion.
It's tight, but the harness clips are secure.
Looks good from here.
That alignment point needs a slight correction to the left. See the deviation on the grid?
Got it. Adjusting the jig now.
Torque set. Confirmed. Acknowledged. Torque set on bolt 4. Moving to the next one. Pressure holding steady, lock confirmed.
Flow rate looks steady here. Check the pressure at junction 7.
Reading stable at 50 psi. No leaks detected. Radio check, ground control, this is Tomcat 1. Tomcat 1, loud and clear. Good copy. Over.